Greeting everyone, my name is Vale Murunga. I'm here to teach mathematics in grade 12, which I will be focusing on the functions, introduction to function and interpretation. Here is our lesson objective. Define a function and identify its characteristic. Secondly, determine the domain and the range of the functions. Thirdly, interpret the basic functions graph correctly. So by the end of the lesson, learners will be able to define the function in their own words, identify the domain and the range from the graph, and also answer the graph interpretations question. What is a function? Function is the relationship between two variables where each input value x has only one output value of y. It means that where there's a value of y, there's a corresponding of what? Of x. So right now we are going to name the type of functions. The type of functions, we have a linear functions, we have a quadratic functions, we have hyperbole, and also exponential. And each of those functions, they have what? The inverse, its own inverses. So right now, out of the type of the functions, they are sharing what? A common characteristics. When we talk about the domain, we talk about the range, we talk about the x and y intercept, the asymptote, and also the axis of symmetrical. So here we are going to apply our common characteristics that we did. Here we will start with what? With the linear functions. Here this is the formula of the linear functions. M stands for what? For gradient, and also C for y-intercept. And also gradient is not just for doesn't not stand for gradient only, but it's also show what? The shape of the graph. So when our gradient is less than 0, it means the shape of the graph will be like this. It means that the gradient is what? Is negative. And this one, the gradient is what? Is greater than 0. The gradient here is positive. This is the shape of the graph. And here we can see when the gradient is equal to 0. When the gradient is equal to 0, this is how the shape of the graph. And then here, when the gradient is passing what? The x-intercept, it means what? The gradient what? Is undefined. So here guys, we're going to apply what we have learned. So right now we're going to apply what we have learned on what? On linear functions. We have given the functions. This is the functions. They're saying f at x is equal to 2x minus 4. This is our functions. So the first question says calculate the x and y intercept. So first, among this, the moment when they say calculate the intercept, if they're saying y-intercept, firstly you must let x is equal to 0. When they're saying let x, when they're saying calculate x-intercept, you must let y is equal to 0. That's what I did here. They're saying calculate the y-intercept here. For calculating y-intercept, you must let x is equal to 0. Here is my x. I put what? I substitute 0, and then I find what? The value of y. So here they're saying what? Sketch the graph of the f at x. So for you to draw the graph, you must know the x-intercept, the y-intercept, and the gradient. So here they already calculated what? A gradient for us. But if it was not calculated, you were going to what? To use this formula to calculate the gradient. Okay, so and this positive 2, it shows that it gives us the shape of the what? Of the graph. It means our graph must be what? Must be positive. It's already positive. So on here we already calculate what? The y-intercept. So here we are going to calculate what? The x-intercept. So we are calculated, and when you calculate the x-intercept, you let y is equal to 0. That's what I did there, and then I found the x-intercept, which is 2, and then I started to plot on my graph. It means more here it will be -4, and here it will be 2. And then the last question, it says determine the range in the domain. When we talk about the range, we're talking about the set of y values, where we are going to find where the graph start and where the graph end. But here, as you can look at our graph, all the values of y on the values of y which are positive and negative, they're already included on the graph. It means that the range will be the y is the element of the real numbers. So domain, what is a domain? Domain is the set of x values. Is the same as what? As y. It means where all the values on the graph that are included on the graph. So here, if you can see the graph here, all the values of x that are included on the graph, and the value of x which is a positive are already included on the graph. So our domain will be what? X is the element of real numbers. Okay. So this is our second function where we are going to apply the common characteristics that we have. So this is we have this is the function of a quadratic function. So don't forget that our a give us the shape of the graph, and this is y-intercept, where the graph cut on the y-axis. So here we have a happy face which is concave up, and the side parabole which is concave down. It means that when a give us the shape of the graph, when a is greater than 0, it means you must know that you are going to have a happy face which is concave up. And here we have when a is less than 0, it means your a will be negative here. It means that your shape of the graph must face down, which is concave down. So we're going to do a hyperbole. So the equation says y is equal to a over x plus q, or x plus p plus q, which is p is the horizontal shift, and then q is the vertical shift, which also is asymptote. Then here a, don't forget that a tells us the shape of the graph. Here is the shape of the graph. When a is greater than 0, this is and it means that our graph will be on the first quadrant and the third quadrant. And when a is less than 0, it means that our shape of the graph will be on the second and fourth quadrant. And then this is examples. We are given this function of 2x minus 3. So here we don't have a plus p. It means that p is equal to 0. So the first question says write down the equation of the asymptote of f. The asymptote of f is p and q, and you can see here we don't have a p. It means that the x is equal to 0, and then the y asymptote is equal to negative 3. And then the second question says write down the domain and the range. So here, if you can see our graph, when you draw our graph, this is our graph. So it means they're saying determine the domain. The domain is the x of the real numbers, where x is not equal to 0, and the range is y is the element of real numbers, where y will never be equal to negative 3, which is this one. And then third question says calculate the x-intercept of the graph. The x-intercept, you are still applying the same law. When they're saying determine the x-intercept, you let y is equal to 0. That's what I did here, and then I found the x-intercept, and also the y-intercept. To do the same, you let x is equal to 0, and then we found that is our y is equal to negative 3, and this is our graph. This is our graph. So here we're going to do our last function, which is exponential functions. So in exponential functions, we have a multiplied by b to the power x plus q plus p plus q, and then we know that those two are asymptote of the graph. So don't forget that a should give us the shape of the graph. So it means that when a here b is the one who's giving us the shape of the graph. So when b is greater than 0, this means this is the increasing function. It means that this is the shape of the graph. And the one that's saying 0 is less than b and is less than 1, it means that is a decreasing graph. Is in between. The number of b is in between. The value of b is in between. And then here we're given an example to solve the exponential form. The first one says we have given h at x 2x to the power x minus 4. The first question says write down the equation of the asymptote. I told you guys this p and q are asymptote. So here we have given q as negative 4. It means our asymptote is negative 4. The second question says determine the coordinate of the y-intercept and the x-intercept. We're still applying the same rule. When we determine the y-intercept, you let x is equal to 0. That's what I did here. I let x is equal to 0, and then I substitute on my equation, and then I found the value of y. Same as x-intercept. You let y is equal to 0. I substitute, and then I found the value of x, and this is our graph. Don't forget when you're drawing a graph, don't make sure that you have you have x-intercept, you have y-intercept, you have the asymptote. Here they're saying asymptote is negative 4, and then I wrote it this is our asymptote, which is -4, and then we have 2 here, which is x-intercept, was also -3 as a what, as a y-intercept. I plugged in the graph. So they're saying determine the range of what, the range and the domain of the what, of our graph. So here range is the element of what, -4 and infinity and to infinity. It means that the graph start here, which is this number is already included on the graph. It is what's -4 to what, to positive what, infinity, and the domain is the element of what, is the element of real numbers, because all the values of x which is positive and y can be identified what, on the graph. So here we're going to focus on the what, on the inverse of this one. So the inverse, we have the steps how to solve the inverse. Firstly, replace x where you see what, y, and the secondly, replace where y where you see what, where you see x, and then after replacing those things, then find the value of what, of y. This is what I did here. Firstly, they're saying this is our equation. Since we have this equation, I just took this equation. Since we have this equation, they're saying replace x, and where you see x, you place y. That's what I did here, and then I plugged the log, and then I found the value of what, the value of y.